10.3, example 2. In this example, we're going to just look at how to graph things given polar coordinates. That's all, by hand. So, in the first problem we're going to look at, all we're given is that r is equal to 2. So we're not given any values of theta. We're not given anything, any kind of direction here. So all we know is that r is always 2. And if we're not given theta, that means for all theta values, r is 2. And so that means that starting from the origin, if theta is pi over 2, then r is 2. So I have this point. If theta is 3 pi over 2, then r is this point here. And so on. So what this actually makes is a circle with radius 2. And the idea here is that no matter where you are on the circle, the distance from the origin will always be 2. And that is essentially what a circle is. If you're the same distance from the origin at every point on your graph, that is a circle. And so these coordinates won't be like 2, 0 or anything. These ones here, they'll be, smaller, but the radius will be 2. So when you just have r equals in polar units, this makes a circle. And this is something I can show you here, because if I trace this out and I let theta become any value, so notice that b, which represents my r value here, is always going to stay the same. And all I'm going to do is rotate it. So as I rotate it, the radius, or r, will always stay the same from the origin. So notice that that makes a circle. All right, the next one I want to go ahead and look at is r equals -2. So the same idea here is we're going to be -2 away from the origin. So if I start at the origin and say I wanted to use theta is pi over 4. But I want to go -2. So I go rotate pi over 4 to here. But then I go -2 this way. Boom. Right? If theta is pi over 2. So that would be this line here. But then I'm going to go -2, so down this way, -2. This distance is -2, -2. And I repeat that process everywhere. And that's going to end up making a circle, with all of these distances being -2. So I can show you how that's going to work here. So if I make this -2, you can see that instead of starting positive, I'm just going to start negative. So what we're going to do now is I'm going to go ahead and rotate this. And it just starts here, and it's going to rotate and spin around. So as we're rotating, you see that I'm -2, but the absolute value is still 2. My distance is still 2. It just started in a different spot. So r equals -2, if I'm going to write it as a description. So r is the distance from the origin. So you want to go 2 units backwards for every angle of theta. Okay, the last one I want to look at is theta equals pi over 6. So what I'm telling you here is that I don't give you r. But what I do give you is that theta is always pi over 6. So here, theta is pi over 6. So I'm going to go ahead and draw that in. It should be about 30 degrees. I didn't draw it very well. But that means that it looks like this. Because r could be 1, r could be 2, r could be 3, r could be 4. I don't know. So when r is greater than 0, it shoots this way. And when r is less than 0, it's going to shoot this way. So it basically, when you only have theta values, you get a line using that theta value.